Okay, so I'll share my screen and just let me know once you're able to see it, okay? Is it visible? Sorry, say it again.
Yes, now it's visible.
Oh, okay. All right. Okay, so finally we are done with chapter 4 and we started chapter 5 yesterday. We are on chapter 5. Okay. Chapter 5. That basically is hypothesis testing. Okay. So, like, I'll give you a quick recap of what we have discussed yesterday. So, like, hypothesis testing is basically a test, right, which we do, and it's not only for maths. Like I told you yesterday, we do hypothesis in biochemistry, physics, and we can do that in any subject. It has nothing to do with stats particularly, right? So obviously, just like any other subject, whenever we have to make hypothesis, we have two options. Like either we'll end up getting a possibility or we'll end up getting b possibility, right? Okay, so let me just write down things. Okay, so statistical hypothesis is basically a statistical statement which may or may not be true. Okay, all right, obviously. Right. And then we should know that we discussed two types. Null hypothesis, which is denoted by H naught. And this is something which we are expecting. Okay, so we write expected slash theoretical. This is something which you had been thinking about already. This is something which
Yes.
we always, use if it's a dice, we say 1/6 and stuff like that, right? We have talked about this yesterday as well. And after null hypothesis, obviously, we are going to have an alternative hypothesis that if null is rejected, this alternative hypothesis would be accepted. It's quite, obvious stuff till here, right? So we denote it by H1 and it is basically changed from theoretical or expected. So let's say I'll give you a quick example. If we talk about a dice and we say that the probability to get any side is 1/6. When I'll talk about alternative hypothesis, all I know is that it is not going to be 1/6. So either it would be greater than 1/6 if it is biased, right? I'll talk about it in detail. Okay, or it would be less than 1/6, or if I'm not sure about that it would be greater than or less than, I would know certainly that it is not going to be 1/6. Okay, we discussed this as well, and then I told you yesterday that if we have these two cases, it is called one tailed test, right? Like I did not explain this, I just told you the terms, and this is called two tailed test. Okay. Okay, so you are clear with all this, all the terminologies and everything which you should know in this chapter, little background and stuff like that.
Yes.
Okay, excellent. All right, so we are good to go. Right. So, okay. So this part is clear. Very well done. Now, there's only one thing before doing example, that in questions, you will see that they ask you, what is the test statistic? Okay. So basically, it's just a little definition. Statistic that is used for hypothesis is test statistic. Okay. Now in questions, which we will do just after this definition in examples, you will see that they would be asking you about the test statistic and stuff like that. Okay. So basically, statistic that is used for hypothesis is test statistic. Now, what exactly this means, I'll tell you. Let's say there's a question which says that okay, so you could carry, I'm reading something, okay, just listen to me.
Okay.
You could carry out a hypothesis test to find out if a die was equally likely to land on 3 as on any other number, right? And like you do that, you do, let's say, 10 attempts, and you get that 3 times. When you roll your die, you got 3 on that side. Okay, so basically you made 10 attempts, you roll your dice 10 times, you made 10 attempts. Okay, and test statistic would basically be denoted by X. This is the test statistic. You'll get a better idea once we'll do proper example. Okay, so let's say it could be that you're rolling a die, you are tossing a coin, anything. Okay, it could be anything, but you are doing that 10 times. Okay, you are making 10 attempts. So test statistic, or X, would be the number of times you got required side. Okay, now obviously this definition is related to the coin tossing and to the dice. Just know this, and after this we will do an example. You will get a proper idea of what test statistic is. Okay, so test statistic is denoted by X. It basically is the number of times you get your required side. Okay, it could be side of your dice, it could be side of your coin, it would vary from question to question. Okay, so don't worry, you will understand everything in this example. Okay, even if you have not understood anything so far, still you would be able to understand everything after this example. Okay, so just don't worry. This is the very first example of this chapter. Okay, okay, so this is the very first example. So the question is, Sanjeet rolls a tetrahedral. Okay, now have you ever come across this type of a die, like, which has this name, tetrahedral? Now it's not that six-sided cube, it is tetrahedral. Okay, which he thinks is biased towards one. Okay, he wants to do a hypothesis test to test his theory, okay, he rolls the die 40 times and counts the number of times it lands on 1. Okay, now this is the very first question of this chapter. Okay, so if you have not understood anything so far, you would be able to, right? So we have like few parts. Part A says describe the test statistic, which we were talking about just before this example, which basically is X. Okay, now let's understand the example and then we'll read the questions, right? So Sanjeet rolls a tetrahedral die. Now this is a different die, okay? Tetrahedral means that it is going to have 4 sides. In a cube, we have 6 sides, but in a tetrahedral die, we have 4 sides. And like if you're interested in knowing its shape, you can search that. You'll get to see it is not.
Triangle.
Yeah, okay, perfect. Right. So like you know that it's not the usual cube with which we play Ludo, right?
Yes.
Okay, excellent.
Yes.
Okay, so Sanjeet rolls the tetrahedral die, which he thinks is biased towards 1. So basically, he's thinking that if he is going to roll the die, he would get the probability of getting 1 is more than the probability of getting any other number, right? Okay, is that clear? This line which I've underlined with blue means that probability which he thinks is biased towards 1, that the probability of getting any other number, let's say in this case we have like 4 sides, so probability of getting any number is 0.25, right? But he's basically thinking that probability of getting 1 would be more than 0.25. Okay, this line right here, which basically means that he thinks the dice is biased towards 1, means that the probability of getting 1 would be more than the probability of getting any other number, right? This is the probability for any number. And how did I calculate this? Just like we used to do 1 by 6 for any side, since now we have 4 sides.
1 by 40.
Sorry?
Will it be 1 by 40, the test statistic?
Yeah, okay, we'll talk about that, but let's read the
Okay.
question first, okay? Okay,
Yeah.
excellent, very good. Okay, right now he wants to do a hypothesis test to test his theory. Like he is expecting that there's something wrong with the dice, that he is getting 1, like maybe he was losing and he ended up thinking that there's something wrong with the dice, which is why he's getting 1. He thought it is biased towards 1, so he wanted to test out his theory. Okay, he rolls the die 40 times and counts the number of times it lands on 1. Okay, so part 1 says describe the test statistic X. Okay, so basically it is the number of times the die shows 1 in 40 rolls. Okay, so it is going to be
Yes.
the number of times the die shows 1 in 40 rolls. So I told you in before this example, I told you about test statistic where I wrote 10 attempts. Okay, at that time I just wrote attempts because that would vary from question to question. If you're rolling your die, or you're tossing something. So here he attempted this test 40 times. Okay, so test statistic is the number of times the die shows 1 in 40 rolls, right? Okay, so far we have no idea how to conduct the test, the results, stuff like that, we know nothing. Okay, we just know how to find out the test statistic. And what is the way? We have a standard way, we have a fixed way through which we will be finding this test statistic in every question. Okay, so we do it this way. It is obviously the question would be pertaining to a particular thing. If it's a die, it would be a side. If it is again, if it is a coin, it would be either head or tail. In this case, it is a tetrahedral die, and we are particularly talking about 1. Okay, so here, number of times the die shows 1 in 40 rolls is your test statistic. This is not something which would vary from question to question. We have a fixed answer for this. Okay, so this is how you'll be answering it in exam as well, right? Is this clear?
Yes.
Are you sure?
Yes.
Okay, very good. Now we have B part, which says write down a suitable null hypothesis. Okay, so we don't know what null hypothesis is. Let's talk about that. Okay, I told you null hypothesis is the expected or theoretical value. Okay, so like if this die has 4 sides, okay, what is the expected value of probability? What is the expected value of probability? If something has 4 sides, it would obviously be 1 by 4. The probability of getting 1 is 1 by 4, right? Like, let's not talk about this question.
Yes.
We're just talking about the theory. We're just talking about what we are expecting. Okay, so the probability of getting 1 is 1 by 4. So this is our null hypothesis, and this is how we denote it, right? With H naught. Okay, so this part is there. I think so. Okay, now we have the third part, which says write down. So far, we have not conducted the test. That would be next section. We're just preparing for the test. We're just preparing for like what would be the null hypothesis, what would be the alternative hypothesis, what is the question about, and stuff like that. Okay. So alternative hypothesis. Okay. Right.
Alternative hypothesis.
Yeah. So any idea about this part? Like alternative, I'll just give you a quick hint. Alternative is changed expected value or theoretical value, right? Like in this part, we use expected slash theoretical value, that which is based on the theory. Okay,
The theory is um,
that we
there is
will
a
get.
greater chance
Yeah. Yes. Excellent.
for
Excellent.
the dice to land on 1, so it'll be
Very well
greater
done.
than 0.25.
Excellent, excellent. Very well done. Very well done. Yes, you're 100% correct. Okay, let me just write that down. Okay. So this basically is okay. So first thing, we write it like this, H1, and probability is greater than 0.25. Okay. So you know this because of this word right here. Okay. This he's saying that it is biased towards 1, so you know that it is going to be greater than 0.25. And again, we are talking about number of times the die shows 1. All this discussion is about the side 1. Okay, right. Now we have the fourth and the last part of this example, which basically is this a one-tailed or two-tailed test? Yes, so basically I just told you about these terms, and you only need that much part which we have already discussed. Okay, so a quick hint is that this D part is related to the alternative hypothesis, right? Now, clearly, here it has been mentioned that it is greater than. So I told you if the probability is greater than or less
It's
than,
one tail.
excellent. Yeah, that would be one tail. And when we are not sure, we
It's two
conduct a
tail.
two-tail test. Very well done. Okay. And how do we do that? We don't know that so far. Okay, so just the thing which we know is that it would be a one-tail test. So are you clear with this part?
Yes.
And like these, all this example?
Yes.
Okay. Now let's talk about another example and then we'll move to the next section. Okay. Example 2. Anna wants to find out if a coin is biased. She decides to carry out a hypothesis test. She throws the coin 10 times and record how many times it lands on heads. Okay. So the very first part is describe the test statistic, that is X, and state its distribution. Okay. All right. So here we have our question. Right. Okay. So basically, Anna wants to find out if a coin is biased. Right now she is not saying if it would be biased or not or stuff like that. She is just saying that like she wants to find that out. Just give me a second. I'm not able to. Yeah. Okay. Now. Yeah. Right. So she wants to find this part out and she is not sure about it. Okay. She decides to carry out a hypothesis test. Okay. She throws the coin 10 times and record how many times it lands on heads. All right. So okay. Now obviously the test statistic is going to be why has it started writing small? Okay. The number of times she gets heads in 10 attempts, right? Is this part clear? That this basically is going to be The number of times. Okay, perfect. Okay, and the second part is new. You have to state the distribution as well. So do you have like a clue and hint is that you have studied this part in AS? Like you have studied such cases?
Hmm.
No idea?
Um, Stated distribution.
Like you have, how many distributions
It's
have you studied?
binomial, right?
Yeah, very well done. Excellent. Okay, and why is it binomial? Because like,
Um,
yes,
because there is a chance of success and failure.
very good. Like either she is going to get heads or she is not. Okay. So this is why in this chapter we will be focusing on binomial distribution, right? So here
Okay.
we are clear about the test statistic. The new thing was distribution. You have said correctly. It is binomial distribution. Okay, so X, that is the test statistic, is distributed binomially. And what am I going to write here and here? So here I have number of attempts in the first blank, right
10.
answer? Excellent. And here we are
The
not,
probability of
yeah,
success.
yeah, okay, so like
But you don't know what that is.
exactly. So we will write P,
Hmm.
right? Okay, perfect. So we are
Yes.
done with the first part. Very well done. Okay, and now do you see how things are linked in S1 and S2? Like there is a link.
Yes.
Okay, now the second part is write down a suitable null and alternative hypothesis. Okay, so what could be the null hypothesis? I'll just write down the notations and you will help me after thinking and after taking your time. So this is going to be H naught. Probability is going to be something. This is for null. And for
That
alternative,
must be 0.5.
okay, so this is going to be,
0.5.
and why?
Because 1 by 2. I mean, it
Yeah,
can either be
excellent.
head or tails.
Excellent, excellent. Okay, because this is what the theory says, right? This is how things have been happening. And this is what might happen in case of a normal coin. Like it is either going to land on heads or tails, okay? But the alternative is going to be, yes, now this might be a bit challenging because here the question just says that Anna wants to find out if a coin is biased or not. Here she is not saying that it is biased or it is unbiased. Here the question says she wants to find out. So the only thing which we can interpret from the statement is that this is not equal to 0.5, right? In the previous part, the statement was that Sanjeet rolls a tetrahedral die which he thinks is biased towards 1. So we wrote in alternative hypothesis that probability of getting 1 would be greater than 0.25. But now the question says that she wants to find out if it is biased or not. Okay, like the question does not say it is biased. Okay, so this is why we will write not equals to 0.5. All we know is that it would not be what we are expecting. So it is not going to be equal to 0.5, what we are expecting, right? In null hypothesis. Are you clear with this part?
Yes.
Okay, tell me honestly if things are making sense to you or not, because you're looking and studying all this for the first time. So I totally understand if you are not able to understand anything, okay? So like, is it clear so far?
Okay, can you explain why it's not equal to
Okay,
0.5
yes, sure,
again?
sure, sure, definitely. Okay, look. Now, when we were discussing alternative hypothesis, I told you that we will have three cases, okay? Either the probability would be greater than something, or it would be less than something, or it would be not equal to something, right? Now, in these three cases, I told you that when we will have like less than or greater than, it would be one-sided, and this one would be two-sided, right?
True.
Now, obviously, this thing is going to vary. This choice is going to vary from question to question, and this would be done as per the question statement. In the previous question, it was clearly written that I've forgotten his name of Sanjeev, okay, that he thinks that it would be biased, okay. So in that case, he was saying that it is biased. He wanted to test out that, like he was expecting it is biased, okay. It is not. He was sure about that. Like in this question, you can see she wants to find out if it is biased or not, okay. But Sanjeev was thinking that it was biased, okay. So this is how you are going to know if something is biased. You will use probability greater than what we have usually. Let's say if it is a normal dice, and we are saying that let's say I say that Ranjani is saying that probability of getting side 2 is like is biased, okay. It is biased, okay. So in that case, you will say it would be more than, it would be more than 1 by 6. And if you say that it is unbiased, like it is not equally likely to get the side 1, and by the fact that you are saying not equally likely, you're trying to say that it is not that likely as likely it is for other sides. So in that case, you will say P is less than 1 by 6, right? And if you are saying that, like, I just want to find out if it is, equally likely for um, a coin to get heads, or if it is equally likely to get 6. So in that case, you are just going to say P not equal to 1 by 6, because like in this case, you are not using the word biased or unbiased. Is this clear? Like here, obviously, the question has the word biased, but what I'm trying to say is that this question, this shows that she is uncertain about the fact that if it would be biased or unbiased. Okay, don't go on the English of this question. Just understand the statement. If one statement is saying Anna wants to find out if a coin is biased, and if there's a statement which says,
Means that she's unsure.
sorry,
But this statement means that she is unsure as to whether it will be
yes,
greater
yes,
than or less than.
exactly,
So we just
exactly.
said not equal to. Okay.
Exactly. Excellent. Excellent. Yes, you have used the appropriate words. Yes. In this case, like she's unsure. She thinks that it would be biased, but like she's not sure. By biased, I mean she does not know if it is more likely to get hit or less likely to get hits, right? She is not sure about that part, but like she wants to find out. And if there's a question which says that she thinks it is biased towards hits, would mean that she is thinking that probability would be greater than zero point 0.5, okay. So this is the statement. If we had this line that she thinks that the coin is biased towards the side heads, in that case, the alternative hypothesis would have been this. But since the statement is that Anna wants to find out if a coin is biased towards the head side or not, this is what you're going to get, okay?
Yes.
So is this clear now?
Yes.
Like you'll get a better idea with examples, okay? Because this is something which is going to change from question to question. But yes, this is the basic idea, okay? Like here the statement clearly is that she doesn't even know, how can we know? But in the previous question, he was thinking that it is biased and he wanted to test that out, okay? Like when you are certain about what you want to test, you conduct your test that way. But here in this question, she is not sure. All she is saying is, Either it would be 0.5 or it would not be equal to 0.5. So that is going to vary. Okay. It's okay if you have not understood this completely. You'll get a better idea with next examples. Okay. Right.
Yes.
Now we have C. Okay, so we have done this. Sorry. Right. Write down the distribution of test statistic if your null hypothesis is true. All right, so what are we going to get here? This distribution of test statistic, that is this one right here. They just want us to plug in our value in P, okay? So like in first part, we wrote P, and now we have two hypothesis. One is null, which says P is equal to 0.5, and the other one is P is not equal to 0.5. So for this part, you are just going to plug in the value of P. Right. So did you understood this part? Did you understand this as
Yes.
well? Okay.
Yes.
Very good. Okay. And then the D part says, is this a one-tailed or two-tailed test? Okay. So you have to tell me this part. Okay. The only tip I can give you here is that this is related to the alternative hypothesis, right? So either it is one-tailed or it is two-tailed. So on the basis of this right here, we decide this, okay? In previous case, we had probability greater than 0.25. So since we had this side, since we had this sign, we said that this would be one-tailed, right? So in this case, we are not sure if it would be greater than or less than. So we would say that this is two-tailed
Two-tailed.
test. We have discussed this already. Are you clear with this?
Yeah, because it's not equal to.
Yeah, exactly, because it is not equal to, and we are not sure if it would be like this sign or this sign. Okay, all we know is that it is not equal to 0.5. Right, so we are done. Okay, so tell me honestly if you're clear with everything, every detail in this question and in the previous
Yes, ma'am,
question.
it's fine.
Okay, excellent. Right, so I will clear everything because now we have to take things to the next level and we have to move to the second section, that is 5.2. Okay. Okay. Now this is the section which we'll be talking about And in this section, you'll see how to conduct tests. And like now we will see if our null hypothesis would be accepted or, alternative would be accepted, right? Now we will talk about acceptance and rejection and all that stuff. Okay, right. Okay. First of all, I would like to explain the term significance level, okay? So it is basically used, this term is used to refer to a chosen probability that implies an unlikely event. Okay. Okay. And then second part is the significance level is the probability of rejecting H naught. Right. Okay. All right. Now, one thing which you should know that all this content is not difficult. Okay. Keep this thing in your mind. These things are new. These things are different. But this is not difficult. In every question, there would be a set pattern and you'll be solving everything, in a similar way. Things would not vary from question to question. Okay. Obviously, basic things would, but like your majority working would be same. Okay, right. Now we are talking about 5.2 section, which has two things: significance levels and rejection regions. Okay, right now we're just talking about significance levels. Significance level would be given as a percentage. Let's say it would be alpha percent, it would be a percentage. Just like confidence interval in questions, you were told that you have 99% confidence interval, etc., etc. Just like that confidence interval, here we have significance level. Okay, so like if you are comfortable with that, you would be comfortable with this as well. Okay, right. Are things making sense, Ranjani?
Yes.
Okay, right. Now significance level is used to refer to a chosen probability that implies an unlikely event. Okay, first thing, just like confidence interval, significance level would be given in the question. Okay, so you don't have to do anything with significance level. You will not be finding it. You would be using the significance level for rejecting H naught. Okay, all right, all right. Now we have in the previous section, we discussed things which were required for conducting tests. And now we are talking about the results, that how are we going to reject the test? How are we going to accept the test? Okay. So is this thing clear that what exactly we're talking about?
Uh, the significance level, right?
Okay, okay, I'll tell you again. In the previous part, 5.1, so far we
Yeah.
know that we're talking about hypothesis testing, where we'll be testing out a statistical parameter. And in the previous section, we have been talking about the initial steps, that what would be our null hypothesis, what would be our alternative hypothesis. And if this thing would be accepted, this would be rejected. And if this is rejected, this is accepted, right? But this is something which you know
Yes.
already. This is something which which anyone would understand. When we are conducting a test, either we'll have this or we'll have this. Okay, so these things are not related to statistics, and this is something which we know already. Okay, Fine. So in the previous section, we just did the initial steps. We just know what null hypothesis, alternative hypothesis would be. In this section, we are going to basically know the results. In the previous part, we have not, we just wrote the terms one-tailed test and two-tailed test, and we did not discuss about how to conduct those tests. Okay. Now we are basically moving towards the result part. Forget about how to conduct tests. Initially, we just talked about the two options we will have, H0, H1. In this part, right now, we're discussing the results. That what results are going to make us reject null hypothesis or accept null hypothesis. Is it clear now? Forget about
Yes.
significance level. I have not explained that. Okay. Okay. Now let's talk about significance level and its significance in finding out the results. Okay. Number one, significance level would be given as a percentage. Just like confidence interval, you had questions with 99% confidence interval, 97% confidence interval, etc. etc. Just like that, this would be given in a percentage. Okay, and I have just used the word alpha. It could be x%, obviously it would be given, so let's not even talk about alpha. Okay, and it usually is 1%, 5%, 10%. Okay, so this is basically a percentage which would be given in your question, just so you can conclude your test, just so you can make conclusions. And how are you going to make conclusions? Let's talk about that part. The significance level is the probability of rejecting H naught. This line basically means that by using this significance level, you are going to either reject the null hypothesis or accept the null hypothesis. Okay, so is this thing clear? That we are
Yes.
talking about the results part. We're talking about that how would we be able to make conclusions. We are seeing that like we are done with the initial things, that what would be our choices, either it would be H naught or it would be H1, but now we are basically seeing that what are uh, our results going to be, right? So this is what is required for the results. Significance level, which would be given. You'll get a better idea in 1 minute. Okay, I'll write down further steps. Okay, and obviously you'll understand everything once we do example. Okay, now there would be a p-value which you will find later on. Okay, there would be a p-value which you already know how to find through S1. We'll talk about it. Forget about that. There's going to be a p-value which you will find. And let's see what is the role of significance level. Now, first step was to write down H naught and H1. Then you will find p-value, how I'll tell you. Directly in 5.2, we're talking about the results part. That how are we going to know if this is accepted or if this is accepted, okay? Right, so p-value is skipped for now. So now we're just talking about the results part, and that is if p-value
Value. Okay.
is, you don't know what p-value is. I have not explained that, okay? If
Yeah.
p-value is less than significance level, H naught is rejected. And if p-value is greater than significance level, H naught is accepted. Okay, okay, fine. Let me just rub the extra things which are going to, confuse you, the definitions and all that. Used to refer. Okay, we just need this part. Okay, right. Okay, now I'll tell you again. Okay, so this is basically written in percentages, it is given. It can be 1%, it can be 5%, it can be 10%, it would be given in the question, okay? And why significance level is required? Significance level is the probability of rejecting H naught. This blue line basically means you will find out how to find p-value. So far, I have not told you how to find p-value. Let's say your p-value comes, let's say it comes 0.02. Okay, this is your p-value. And your significance level, let's say, is 5%. Okay, significance level is 5%, which basically is 0.05. Now you know that your p-value that was 0.02 is less than your significance level. So this H naught would be rejected. You will find, you will learn how to find p-value. I have not told you, I have not explained that. You will know that when we will do examples. You will find p-value. Once you have your p-value, the significance level would be given in the question as a percentage. All you need to do is you have to convert this percentage into this decimal by dividing it by 100. And this is the part which you need to focus on. If this p-value is less than this significance level, you will say that your null hypothesis H naught, which was the expected or theoretical one, which we have been doing throughout our lives, is rejected. And if let's say your p-value was 0.06, which is greater than your significance level, which was given in question, you are going to say that H naught is accepted. Okay.
Yes.
So are you clear with this now?
Yes.
Significance level is just a percentage which you use as a reference to get your answer. If your p-value is less than significance level, you are going to reject the null hypothesis. Okay, and when you reject null hypothesis, alternative hypothesis is accepted automatically. Okay, and if p-value is greater than significance level, which would be given in question, you accept your null hypothesis, and obviously the alternative hypothesis would be rejected automatically. So is this clear?
Yes.
Sure.
Yes.
Why am I thinking that it's not clear? Tell me honestly.
No, it's clear.
Okay. All right.
What is p-value again?
Yeah, p-value is to be calculated. P-value, I have not, p-value is probability. There is some probability, you'll get to know that shortly. Okay, we have not discussed that. So I'm going to write down everything neat and clear in steps, and then we'll do example. Okay, I have not told you how to find p-value. I will do that once we are on an example. Okay, because it is much better to explain things there. But trust me, you would be telling me how to find p-value. You already know that. Okay, you have been finding
Hmm.
probabilities. So yeah. Okay, now I'll just clearly, neatly write down the test steps. Okay, you can note down this as well because this is important. Okay, carrying out. Are you finding it difficult? What?
A bit difficult.
Yeah, because it is different, right? You should use the word different, not difficult. Obviously, and like you were clear with fourth chapter, right? So you were so comfortable with it. In fact, you were telling me when we were discussing the last section, you were telling me things, and I was just writing down everything. So you will get comfortable with this chapter. It's just the second section, okay?
Okay.
Okay. Carrying out a hypothesis test using p-value. This p-value would be discussed in example. Right. So very first step is to define the test statistic X and state its distribution. Okay. Second step is we'll be following these steps in coming examples, so it is important. You need to state the null and alternative hypothesis, and this as well, that whether the test is one-tailed or two-tailed. All right. And the significance level, which would be given, okay? Right. Then you need to state the distribution of X if H naught is true right? Then you have to, I'll explain everything. I'm just writing down. State the criteria for rejection of H naught. Okay. Find the p-value of your test result and compare it to the significance level. Things will make sense in a minute, okay? Don't worry. Right. And then finally we have conclude if H naught is accepted or rejected. Okay, fine. Okay, now look. One thing I would like to tell you again, if you are thinking of this chapter as difficult chapter, please don't do that. It's just because like you have not seen any examples so far. Things are, moving around in your mind here and then, that what is test statistic and what is p-value and what is significance level. It's just because you have not done any example. Okay, I'll explain these points. If you understand all these points, you would be able to do every question of in this chapter, right? Okay, so let's talk about this. So we are discussing how to carry out a hypothesis test using p-value. Okay, right. So basically, if you are uncertain about something, you want to conduct hypothesis test to see if your null hypothesis would be accepted or alternative hypothesis would be accepted. By null hypothesis, And alternative hypothesis, I mean, before testing out anything, you have two options. Either you get A or you get B, right? So like this is what null and alternative is. Okay. Define the test statistic that basically is denoted by X. Okay, let's talk about this part only. So in this part, let's say you are trying to see if your dice is biased towards 1 or not, right? Let's talk about a regular dice in which you have 6 sides, and you are just interested in knowing if your dice is biased towards 6 or not. By this line, that if it's biased towards 6 or not, I mean the probability of getting any side is 1 by 6. Here you think that the probability of getting 1 is not 1 by 6. Either it is more than 1 by 6 or it is less than 1 by 6. Okay. So this discussion is about the side 1 of your dice. So here, and you are you are rolling your dice 10 times. Okay. So here the test statistic, which is denoted as X, is basically the number of times you are getting 1 in 10 rolls. Okay. It is the number of times the die shows 1 in 10 rolls. So you are clear with test statistic. We have discussed example, right?
Yes.
Why are you so upset? Like, are you upset?
No, it's just no, it's fine.
Okay, okay, okay. Don't worry, okay? And state its distribution. Its distribution is going to be binomial because so far we know either it would be one side or it would be any other side. Since our discussion is based on one, distribution would be binomial, okay? So this would be binomial. So far we have only discussed this case, okay? Is it clear?
Yes.
Okay, let me explain everything and then I'll ask you what is not clear, okay? And then I'll explain it again. Okay. Then the second point is state H naught, that is null hypothesis, that is the expected one. In case of a die roll, you say 1 by 6 for any side, and H1 is the alternative hypothesis, okay, which is denoted by H1, and it would be changed from the theoretical or expected value, okay? Right. Whether the test is one-tailed or two-tailed. Okay. And then you need to state whether the test is one-tailed or two-tailed. You are going to do that on the basis of your alternative hypothesis. Okay. On the basis of H1. If the probability is greater than or probability is less than, you're going to say one-tailed. And if your probability is not equal to, you're not sure if it is greater than less than, you are going to say two-tailed. Okay. Right,
Okay.
Transit? Okay. And
Yes.
and significance level, this part would be given. Okay, this part would be given. Right. Okay. Now the third point is state the distribution of X if H naught is true. Right. Here in this part, you know well, when we stated the distribution in first part, in the beginning part, we just write down X is binomially distributed. We write number of times and we write P. After the discussion of H naught and H1, in this part, we just write down X, B, number of times which we are attempting the experiment, and we write down the p value, okay, the probability of success, okay,
Okay.
right. Then state the criteria for rejection of h naught. And what is the criteria for rejection of h naught? That if your p value, which you don't know how to find, if your p value is less than the level significance level, which would be given as percentage, you say that your h naught would be rejected, right? I told you, if p value, which you don't know how to find, is less than this significance level, your h naught is rejected. So you have to state that criteria, okay? And you will do it this way. You just have to write if p value is, it's just in this part we're just discussing how to carry out every part. Once we carry out every part, you would be able to understand things 100%. Okay. Right. So you know how your H naught would be rejected. Okay. Then you have find the p-value of your test result and compare it to the significance level. Okay. Now you have to find p-value, which you will do. Okay, and compare it to the significance level. Okay, we already know that. We will find our p-value and we will compare it with the significance level and we'll know if it is rejected or accepted, right? And conclude if H naught is accepted or rejected. Clearly, once we state the criteria, we know that next steps would be to find the p-value, finding p-value, and comparing it with the significance level. So we know that if p-value is less than significance level, our null hypothesis would be rejected. And if it is greater than significance level, it would be accepted, right? So we have just discussed this much, okay? Are you clear with this part?
Yes. Yes.
Okay, excellent. Now let's just, I just want to keep this somewhere and, like, did you note all this? Eh,
Yes.
Okay, fine. So because I would want, to have a reference. I have all this noted already. If you haven't, you can just take a picture.
Yeah.
Okay, just take a picture of screen and then we will talk about the example, because in example we'll be following all these steps one by one. So yes, are you done with the picture?
Yes.
Okay.
I already noted it down.
Okay, perfect, excellent. Okay, now it's time for the example. You will understand everything. This is the very first example of the new section 5.1. Okay, now the example is, again we have Sanjeet in this example. Okay, so to test whether his tetrahedral die is biased towards one, Sanjeet rolls it 8 times. Three of these rolls the die lands on one, carry out a hypothesis test at 5% significance level to test Sanjeet's claim. Okay. Now, the question has too many details which would be required to test whether his tetrahedral die is biased towards one. Sanjeet rolls it 8 times. Okay. In three of these rolls, the die lands on one. Like in total, he rolled his die 8 times, and out of these 8 attempts, in three, his die landed on 1 in 3 attempts, okay? Carry out a hypothesis test at 5% significance level to test Sanjeet's claim. Okay, so we have 1, 2, 3, 4, 5, 6 steps. We have 6 steps in order to find that. Let's just draw one, two. Okay, so like uh, we'll be following 6 steps. So we need like at least 3 columns, right? So okay. So here's the solution. So can you please read for me and tell me what is the first step? Like the step which you have noted down. Yeah, are you there?
Yeah, sorry, I was muted there.
Yeah.
So
Okay.
the first step is to define the test statistic
Excellent. Okay. So
and
how do
state
you
its
define?
distribution.
Very good. So how do you define test statistic? It's basically X and
X is binomially distributed.
very well done. Very
B,
well done. But what is your test statistic?
test statistic is,
It is related to the number of attempts and stuff like that.
yes, 3 by 8.
Yeah, but you write it down this way, okay? Number,
Yeah,
no. You don't write it down as 3 by 8, okay? No. It's just an English definition which you write down for this test statistic, okay? It's not a fraction, okay? Be very clear. You just write down number of times die lands on 1 in 8 throws. Like you might say that, like, wait, you are technically correct. You are technically correct that yes, if we are saying X is number of times die lands on 1 in 8 throws, that basically is 3, right? But here basically we are conducting the test to find out what actually is, okay? So in this part, when they are saying to write down the test statistic, you just write down that this is how you define the test statistic, okay? You just have to define it. They don't want you to write down this 3. They just want you to know what exactly the test is about. So this test is basically about number of times die lands on 1 in 8 throws. You are correct, it is 3 out of 8. But since we are conducting the test, and after that we will know what actually is the situation, okay? So you can also see here they are using the word define. They are not saying state or like find the value or what is. They want you to define this, the test statistic. So in this case, we're just talking about the dice with side 1 and 8 throws. So they just want you to write down this. Okay, I hope it's clear. Is it clear? Are you there?
yes, it's clear.
Okay. Right. And the second part is to write down the binomial distribution. So X is binomially distributed with what and what is going to come? Right?
Yeah, 8 and P, because we don't know the,
Excellent. And are you clear about the test statistic as well? Like technically you
yes.
are correct, but they want you to define it, okay?
Can't P be 3 by 8?
No, no. Because like here, this is a tetrahedral die which has 4 sides. So you can technically the probability of getting any side is 0.25, okay? Like this is something which happened in his case. If I play ludo and I get 6 every time, that cannot be the actual probability, okay? Like when we talk about probability, we just say, when we're playing ludo, some people most of the times they get 6 and some keep on getting 1. That does not imply that it is going to be the actual probability, okay? So this P is basically what theoretically is correct, what you have been doing in S1, okay?
Yes.
Right. Okay, so we're done with the step 1. Now it's step 2. Can you please read step 2?
Step 2 is state at 0 H1 whether the test is one-tailed or two-tailed.
Okay, very good. So what
And the
is,
significance.
yes. So what is H naught, H0? It is the probability which we are expecting, which would be theoretical. In case of a tetrahedral die, it is going to be, it has 4 sides, so it is going to be
1/4.
excellent. Okay, 0.25. Very well done. And if I talk about the alternative hypothesis, what is that? P greater
That will
than,
be, yeah, greater than 0.25.
very good, well done. And if tell me if it's one-tailed to two-tailed. Yes, we have this sign.
It is one-tailed.
Very well done. Look, you're telling me everything. It is one-tailed. Okay. And the last thing is significance level. What is significance level? It is given in the question.
Yes.
So what exactly is the significance level? It's here.
5%.
Very good. Okay. Excellent. 5% is the significance level. Okay. Now, what is the third part? Third step? State the distribution of X. Okay. Now, since we have stated this H naught, we can state the distribution properly. So it is step number 3. So X, that is the test statistic, is binomially distributed with 8 number of rows and probability is 0.25, right? We are done. We have done first 3 steps. Okay. So far, is it clear?
Yes.
Okay, very well done. Now let's use different color, yellow. Okay. Now it is step number 4. And you have to state the criteria for rejection of H naught. Okay. So for stating the criteria, what you know is that if p value which you are going to find is less than your significance level, that basically is 5%. So this means if p value is less than 0.05, your null hypothesis would be what, Ranjani? Accepted?
Yes.
Rejected. Okay,
Accepted, right? Because it's, no, it's less. If it's less,
yeah,
it's rejected.
yeah, very good. Okay, yeah. Okay, so we are done with the fourth step as well. Now it's the time to talk about p value, because the next thing is to find p value. Okay, now here some extra information is given which was not given in the previous part, and this information is right here, which you were using somewhere else, but now it would be used. Okay, so this part, three three of these rolls, in 3 of these rows the die lands on 1. Okay, so this p value is basically going to be, this p value is basically going to be probability of X greater than equal to 3, right? You have to find this probability, and you know how you are going to find that. I mean, obviously, I'll be telling you that. But through S1, this is binomial distribution. It is greater than equal to 3. We don't know how to do things this way. We will take 1 minus probability of x less than 3, right? And then for this part, we'll just do probability of x equals 0 plus probability of x for 1 plus probability of x for 2. Okay, now till step 4, we know that if p value is less than 5%, h naught would be rejected. But what is this p value? We did not know about this before. But now I just told you that this is basically the p value. The p value for x greater than equal to 3. And what is 3? Number of times die lands on 1 in 8 throws. Okay, so if this number of times is more than 3, this is going, the probability of getting um number of times more than 3. Is this thing making sense to you?
Yes.
If you are getting 1 side 1 more than 3 times, the probability of getting side, I like the English here, it basically is the probability of getting side 1 more than 3 times. This is what this p value basically means. Okay, when you will find out p x greater than equal to 3, this basically is probability of getting side 1 more than 3 times, right? More than or equal to, because like we have more than equal to sign here, right? So look, I repeat, I'll explain everything again. Okay, don't think that like this is a fixed method. It's this section statistics in general has a fixed way of doing things, and this is how you must be clear with step 1, right? When you have to just state what x is. X is the test statistic, which basically is the number of times die lands on 1 in 8 throws, right? You clear with one step?
Yes.
Okay, you must be clear with step 2 as well, where you're finding the alternate and null hypothesis, right? This is what we have. This is what we have been doing in S1 as well. And this value right here is basically changed version. So we don't know about that. Okay, like that might be greater than, less than, or not equal to. Okay. Then in third part, we just stated the distribution again. In fourth part, we have just mentioned the um criteria for rejection, okay, which I told you that if your p value is less than your significance level, your h naught would be rejected. And now it's time to talk about this p value. This p value would basically be a probability of what thing? Of your test statistic being greater than or equal to 3. And why did we use this 3? Because it was given in the question. 3 is the number of times when you're getting side 1 in 8 rows, right? Are you clear with this thing?
Yes. Yes.
Okay, okay, I hope so. Okay, now what is the next step? Step is to find p value, right? So we are basically on step number 5, where we are trying to find p value. So basically p value is to be calculated this way, which basically we cannot find for this, so we do it for 1 minus p x less than 3, and we have 1 minus, now obviously for probability for x less than 3 is probability for x equal to 0 plus probability for x equal to 1 plus probability for x equal to 2. Because obviously if x is less than 3, either it would be 0 or it would be 1 or it would be 2. Do you know this thing? The thing which I'm writing in green, I'm assuming that you know this through S1. If you don't know, I can explain this as well.
Yes, I know this part.
Okay, very good. Okay, excellent. Okay, now let's find out this part. So it would be 1 minus. Okay, so what is the probability of x equals 0? We use that formula, NCX, right? So it is NCX. Then we have probability of success, probability of failure. Do you remember this formula now?
Yes. Wait.
Okay, I'll write it down. I'll write it down. Okay.
E to the power x and q to the power n minus r. It was something like that.
Yes. Very good. Okay. But here I'll tell you how to do it.
But
Okay.
instead of x, we used to use NCR, I think, right?
Yeah,
Or
but now we have exactly we have NCR in general. Like you'll find NCR on calculator as well. But now it's statistics. We're talking about x. Okay. So n is 8, x is 0, this 0. So C 0, and probability of failure is 0.75 to the n, that is 8. I think I should write down the formula first. Okay, I'll just take 1 minute. I'll just write down the formula and then we'll continue this example in next class. Okay, but how am I going to write everything again? I'll do that. Okay, so
you can take a screenshot and paste it later on. Oh, you can't paste. No, you can paste
don't
it.
worry. I will not take your time. Just give me a second. I need to write down the formula. Because I have been studying so many formulas, these terms, every time I mix them up. So it is basically probability okay, so we write it down this way. I'm just stating the probability. Okay, probability of x is NCX p to the x into q to the n minus x, right? So this is the formula, right? We'll do it later on. You just have to plug in values, you'll get probabilities. Once you have your probability, which means you have your p-value, you need to compare that with your significance level, and if it is greater than, less than, on that basis, either it would be rejected or accepted. Okay, so like are things making sense now? I'll stop the
Yes.
recording. Okay, just give me a second. I have to stop the recording.